Hi there, in this video I'm going to take you through power functions. What are power functions? Generally, power functions are of the form f of x is equal to ax to the power p. This is the general representation of power function. As the name denotes, power, exponents, right? So these are functions that is carrying an exponent. But take note, there are some conditions underlining it. The a here should be non-zero. That is one thing you should take note of. So a is a member of all row numbers minus 0. That is it. It shouldn't be 0. Okay. Now p can take in three forms. P can be a positive integer, p can be a negative integer, and p can be a rational number in the form 1 over n, where n is not equal to 0. The nature of p will determine the type of power function we are dealing with. When p is positive, I'm going to have what we call a monomial. Monomial. So monomial is when you have ax to the power p, where p is greater than 0 or greater than or equal to 0, because when it's 0, you still have a monomial, right? And you can clearly see that a monomial is just a single unit of a polynomial. So if I have a series of these adding up, I'll get what we call a polynomial. But when p is greater than or equal to 0 or positive integers, then I'm going to have a single monomial. Then the next thing is what we call, when p is negative integer, we call a reciprocal function. Reciprocal function. So a reciprocal function arises from a power function that has a p of negative number. So ax to the power p, where p is equal to, or where p is less than 0, yes. So we're going to have something like a over x squared, a over x cubed. We're going to get a reciprocal function, okay, because p becomes negative. Now, the third part is what we call a radical function. Radical function. When you say a radical function, this is when p is a fraction. So if I give you ax to the power p, so let's say p is equal to 1 over 2. What am I getting? I'm going to get a to the power x 1 out of 2. And you know that this is the same as a root x. And this is giving me a radical. If p is equal to 1/3, you surely get a third root of x. So whenever p is represented as a rational function, then obviously you're going to get a radical sign in play. That is why we call it radical function. Reciprocal, the monomial, and the three different types of power function. Now, taking them one by one, if you have a monomial can be a constant function, right? A monomial can be such a, yes, because when p is 0, I have a monomial to be a. I can have a monomial to be ax. I can have a monomial to be ax squared, and in that manner, okay? So that is a monomial. So let's consider a simple monomial f of x is equal to 1. This is where p is 0, because when p is 0, there wouldn't be any x value here. So you can say that a constant function is a special type of power function where p is 0, right? So when I draw this, obviously I'm going to have my 1 here, and I'll have a line passing through my 1 like that, okay? So this is my x. So now, as usual, the domain for a constant becomes row numbers. The range in this manner becomes what? 1. That's all. Now, that was just a simple monomial I chose. Now let's see this monomial f of x is equal to x. Drawing a graph of this, I'm getting a line passing through the x, the origin, right? So this is the same as y is equal to x. When x is 1, y is 1. So 0.11, 22, 33, 44. It will be giving you a line passing through the origin with a positive gradient. If you want to find the domain of this, the domain is simply set of what? All row numbers. That is the domain of this. And if you want to find the range of it, the range is also a set of all row numbers. Now, let's quickly move to what we call reciprocal functions. It's still under power functions, so reciprocal functions. reciprocal function. When we say reciprocal function, as I explained earlier, ax to the power p, where p is equal to 1 over n, where n is not equal to 0. Yeah. So when you have this expression, meaning that we should expect a square root sign, okay? Expecting a square root sign, let me give you an example. I'm going to have f of x is equal to x to the power negative 1, right? So, sorry, this reciprocal, not radical. Yes, I'm trying to make a mistake here. So this one p is negative, sorry. So this one is negative integers, okay? When p is negative. So example is this what I have here. So when I have f of x is equal to x to the power negative 1, how do I determine the domain of this reciprocal function? The domain can be any. I can rewrite this as 1 over x. This function can take every input except 0, so the domain becomes r minus what 0. This is a simplified form of the domain. A set of foreign numbers except is what 0. Now, what will be the range? The range obviously can also be what? Can the range be 0? No, the range can never have 0 in it. So it's as well as r minus what 0. The range can't have 0. This here can't produce 0, and it wouldn't even take 0 as well. So let's see something at a radical. So radical functions. So for radical functions, example is f of x is equal to square root of x, where p is equal to 1 out of 2, right? That is a radical function. So for something like this, the domain simply gives us only positive real numbers, right? Or you can say that r plus. This because square roots doesn't accept negative numbers in the real numbers domain. What will be our range? Our range will also give us a set of what? Positive real numbers, because it can give a negative solution as well. Thank you for being with me in this video. Kindly like, share, then you subscribe. Please see you in the subsequent videos.